Hello students, welcome to Narayan PU College online classes. So we have completed P block elements. So total 4 groups, 15th, 16th, 17th and 18th groups we have completed. And here based on that we will discuss in this class competitive. Clear? So open the competitive book volume 3. Clear? So in this volume 3 they have given see combination means 14th group and 15th group questions combinedly they have given here. Clear? But I will not discuss here about the 14th group elements that it was there in the first year, or it is there in the first year only. So which questions which are there in the 15th group element, and those questions only I will discuss here. Clear? See now volume 3 page number 25. Clear? Exercise level 1. Okay. So see that one in this one question number 3. Question number 3. Clear? So question number 1 and 2 which I am leaving, and those belongs to the 14th group elements. Clear? So now correct the sequence of decreasing in bond angle of the following hydride is. The following hydride is. Clear? So here NH3, NH3, PH3, ASH3, SBH3, ASH3, SBH3. Clear? So they are asking decreasing in bond angle of the following. We have already discussed this bond angle. Clear? So you know that if you take NH3, this is NH3. Clear? Hydrogen, hydrogen and hydrogen. You know that nitrogen is more electronegative than the hydrogen, so that's why these bond pair electrons are very close to which one? Nitrogen. So when they are very close to nitrogen, and here you see, and there is a repulsion between the maximum repulsions among the bond pair and bond pair electrons. So that's why, and here there will be repulsions, and so to avoid that repulsions, these two bonds will move away from each other, and this will move here, and this will try to move in this way. Clear? Then what will happen here? Bond angle increases. Clear? And if you take here SBH3, if you take in this case, this is the bond angle. Clear? So this is bond angle in this case, and hydrogen and bismuth. Clear? And antimony, if you take arsenic, antimony and bismuth, and here you know in this case hydrogen and Sb, so electrons will close to hydrogen, because as you are moving down the group electronegativity decreases, so that's why, and these bond electrons are very close to near to hydrogen. So then what will happen here, and these are away from each other, so that's why, and they try to come close till they experience the repulsions. So that's why bond angle is what it is here, decreasing, and here bond angle increasing. So that's why what is the bond order here? As the electronegativity increases, bond order, bond angle, not bond order, bond angle also increases. So that's why this is the decreasing order of which one here? Bond angle. Okay. So this is the question. So what is the option now here? Your option is option 1 is the correct one. Clear? Next one. Fourth one. Question number 4. So the low reactivity of nitrogen is due to nitrogen. I already mentioned nitrogen is chemically inert because of its high bond dissociation energy. And why? Because means between nitrogen and nitrogen, which bond is there here? Triple bond. To break that one, you have to supply a lot of energy to involve into the chemical reaction. So that's why it is a chemically inert. Why? Because of high bond dissociation energy. Option 4 is the correct one. And the next one. So next one is see the question number 10. Clear? Question number 10. Remaining all questions are belongs to 14th group. Clear? So which of the following does not undergo hydrolysis? Clear? Which one is does not undergo hydrolysis? So the same question I have mentioned in the when we discussed about the nitrogen halides. Clear? NF3 does not undergo hydrolysis. Why? Because it is a, the bond between the nitrogen and fluorine is very strong. This bond is what it is here. This is strong. Why it is strong? Because you know nitrogen is also small and fluorine also what it is small, and it will also means use the 2p orbital, and it also use the which orbital? 2p orbital. So 2p orbitals are smaller than the 3p orbital. So when orbitals are small and overlapping will be and the efficiency of overlapping will be very high. So that's why this bond will be strong. So that the NF3 will not undergo hydrolysis. Clear? And then same question number 14. See the question number 14. Clear? So which of the following properties of white phosphorus are shared by red phosphorus? Means they are asking which property is similar for the red phosphorus and white phosphorus. For the red phosphorus and white phosphorus. See now here, in this case what happened? It dissolves in CS2. Clear? You know that I have already given one table and differences between the red phosphorus and white phosphorus. Clear? So in this case, I have given already the point here dissolved in CS2. Means you know that white phosphorus dissolves. White phosphorus dissolves in what is known CS2, and but insoluble in water. Insoluble in what is known water. And white phosphorus insoluble in water but soluble in CS2. But you know red phosphorus I have given. Red phosphorus neither soluble in water nor CS2. It will not dissolve in what it is not here CS2 and also in water. So first one is different. Clear? It burns when heated in air. Clear? It is okay. Why? Because I already mentioned and both white phosphorus and red phosphorus. But reactivity of white phosphorus will be very high. So that's why immediately it will form P4O10. But this is white phosphorus. This is what it is not red phosphorus. Red phosphorus also react with the oxygen. It forms the white dense fumes of P4O10. Clear? So both will react, but here react at room temperature, but here it needs some temperature to react with the oxygen. So this is the common property for the red phosphorus and also for what it is here white phosphorus. Here and next one. Next one is it reacts with the NaOH to give pH3. Clear? So I already mentioned white phosphorus. What it is here? White phosphorus when reacted with NaOH. When reacted with what it is here? NaOH. Then what you will get for compound here? You will get the compound pH3 and sodium, NaH2PO2. Clear what this is? And you will get phosphine. This is the one of the main preparation for the what it is here? Phosphine. Clear? And in this one, it is sodium hypophosphite. What is this compound here? Sodium hypophosphite. Sodium hypophosphite. Clear? So in this one, you are getting what it is here? pH3 and which one? White phosphorus. I mentioned there you see P4 and red phosphorus with the NaOH. There is no reaction. There is no reaction. Only white phosphorus will react with the alkalis and gives the phosphine, and this is one of the good method to identify which one is the red phosphorus and which one is the white phosphorus. So white phosphorus with alkalis gives the mainly the NaOH and produces the phosphine, but not red phosphorus. Clear? So that is difference. So it phosphorescence in air. White phosphorus, it burns in air, which can be seen in the dark, that called as a phosphorescence or chemiluminescence. I have already mentioned. Clear? But white phosphorus will not means it won't be a it won't give the it won't burn in the air at room temperature. Clear? So that is also difference. Which one is the common here? Second option. Second option is common. Second option is common. Clear? Next one. See the question 16. Question number 16. Question number 16. Clear? Which one of the following pentafluorides cannot be formed? Clear? Which one will not be formed? NF5 cannot be formed. Why one here? NF5 to form, nitrogen should have how many unpaired electrons? 5 unpaired electrons should be there with the nitrogen. Clear? You know nitrogen what it is? 2s2. You know 2p3. Clear? 1, 2, 3. So how many unpaired electrons it has? 5 unpaired electrons. And you know it doesn't have d orbital. Is there nitrogen having any d orbital? No. Nitrogen doesn't have d orbital, so that's why this electron won't go here. So that's why. And when you know nitrogen always forms 3 bonds, and maximum nitrogen can form 4 bonds. That too when it donates its lone pair of electrons. Clear? It cannot form how many bonds over here? 5 bonds due to the absence of which orbital? D orbital. So that's why NF5, clear? And you know cannot be formed. Next one. See the question number 18. Question number 18. The mixture which is used by C divers for the respiration is off. You have already studied this one in the solution chapter, also in result applications. Clear? So what is that one here? Helium and oxygen. Helium and oxygen. You know helium, why we will use the helium? Because that oxygen, you know, if it is oxygen and nitrogen, and you know oxygen and first option is there, N2 and O2 is there. You know N2 and O2 is, if you filled the oxygen cylinder with the oxygen and N2, what will happen? N2 it will be easily dissolved in our blood when we entered into the, you know, deep sea. Due to the pressure increases, when we are in water, pressure increases, automatically solubility of the gases also increases. Clear? So N2 it will dissolve in high pressure. When we come to the surface of the water and pressure decreases, so that's why oxygen it will be taken by the means oxygen it will dissolve in our blood, but nitrogen it is no use, so that's why it will come out through the blood cells and we will get so much pain, and the disease we will call as a pains. To avoid that, clear? What we will use here? Helium. So that's why your option is option 2. Next one. Question number 21. So next one is, see the question number 21. So what is false about N2O5? So N2O5 we have already studied, nitrogen pentoxide, clear? So dinitrogen pentoxide, and it is a anhydride of, if false we have to identify, it is anhydride of HNO3. What is HNO3? You know, nitric acid. It is anhydride of HNO3. You have to identify whether it is anhydride of HNO3 or not. What I said here, how to write anhydride? I said you have to remove the water molecule from here. To remove the water molecule, how many hydrogens are required? 2 hydrogens, one is there, so multiply with this one, 2. Then what will happen? Remove 2 water molecules here. H2O, this is anhydrous. Remove the water molecule. Then what is left? You write here N2O5 will be left. That is N2O5. So N2O5 is an anhydride of which one? HNO3. Correct only. So next one. It is a powerful oxidizing agent. I already mentioned here. N2O5. N2O5 is there. So you know what is the oxidation state? That's why. Nitrogen, whenever any element, whenever it is in its highest oxidation state, if it acts as oxidizing agent, then it is a very, very powerful oxidizing agent. Okay? So it can give the oxygens to other compounds easily. I already said nitrogen oxides are, you know, some of oxides, they can act as oxidizing agents. Clear? Next one. Solid N2O5 is, you know, called as Nitronium Nitrate. This is also I mentioned here. Nitronium Nitrate. In the solid state, how it will be existed as N2 plus, and what it is NO3 minus. This is in the solid state, it is in the form of ionic state. So that's why this is Nitronium Nitrate. Can also be called as this one, Nitronium Nitrate. The structure of N2O5 contains no NO bond, means coordinate bonds. There is no coordinates bond they are saying. Write the N2O5 structure here. I mentioned here 2 nitrogen atoms. Clear? So here double bond O and another one will be the double bond O. Shall I write what this is? Now, how many oxygens are there? 5. So nitrogen forms how many bonds here? 3 bonds. So here there is 3 bonds. Clear? Nitrogen can form maximum how many bonds? 4 bonds. When that too it donates its pair of electrons to other. When it donates pair of electrons to other, it will form which bond? Coordinate bond. So that's why, and it will form one coordinate bond with the oxygen and another one with another coordinate bond with the another oxygen. Okay? So how many coordinate bonds are there in the N2O5? There are 2 coordinate bonds. This is and this is. This we will call now. We will not call as a coordination bond. These are covalent bonds. Okay? Coordinate bond when it will form? When one element donates pair of electrons and another element has to accept those pair of electrons. That is, this is what we will call donative bond. So your option 4 is correct one. It is false. Okay? Next one. And 23rd question number 23rd. Okay? See, which of the following oxide is most acidic? They have given N2O3, P2O3, AS2O3, SB2O3. Clear? So this is also very clearly we have discussed in the PU class. Clear? Same here you see oxides but different central atom. Clear? Oxides of different elements. When oxides of different elements, so how we will consider the acidic nature, and you know I have given an acidic nature in this case directly proportional to electronegativity. Clear? So acidic nature is directly proportional to which one? Electronegativity. If same elements of oxides are there, then acidic nature is directly proportional to its oxidation number, oxidation state. Clear? So that's why among these, which one is more electronegative? Nitrogen. So that's why these oxide, nitrogen oxide is more acidic. So that's why option 4 is correct one. Clear? Next one. 28 question. Clear? So least acidic and most acidic oxides of nitrogen are, see from here, nitrogen, we have nitrogen oxides N2O, NO, N2O3, N2O4, or NO2, or N2O5. These are the nitrogen oxides. Which one is the most acidic and least acidic? Now just now only I mentioned you see about, and here oxides of the same element. Here electronegativity we cannot compare because here electronegativity for the nitrogen is same for all the oxides. So in this case you have to say the oxidation state. As the oxidation state increases, you know what will happen here? Automatically acidic nature increases. Clear? So that's why if you see here which one is the least and which one is the most acidic means N2O is the least and N2O5 is the most acidic. Clear? So next one. Next one is direct question 32. Aquaresia is a mixture of. So I already mentioned what is aquaresia. Clear? So 3 parts of HCl and 1 part of HNO3 is called as a aquaresia, which is used to dissolve the noble metals like gold and platinum. Clear? So what is your answer here? Your answer should be option 1. Clear? Next one. 35. Question number 35. Clear? So the number of molecule of water needed to convert 1 molecule of P2O5 into orthophosphoric acid. Clear? So P2O5 into orthophosphoric acid. Phosphoric acid formula what is H3PO4. How many moles of water is required? They are asking. Clear? You know that actually P2O5, phosphorus pentoxide. I already mentioned. Nitrogen forms many number of oxides, but all oxides are monomers only. And oxides of phosphorus, arsenic and antimony are dimers. Clear? Oxides of phosphorus, arsenic and antimony are dimers. So that's why here what they have given? P2O5. P2O5 will be in the form of which one? P4O10. It is in the form of dimer. So now from this you have to prepare the, by dissolving this into the water, we will prepare the phosphoric acid. What they are asking here is how many moles of water molecule required to convert the P4O10 into H3PO4. Clear? So balance here. How many phosphorus atoms are there? 4. So I have to multiply this one with the 4. Then, and how many hydrogens are there? 4 into 3, 12. 12 means I have to put here how many? 6. So now all oxygens also balance, and 4 into 4, 16. Here 10 and here 6, 16. So how many moles of water molecule required here? 6 moles of water molecule. So next one. See the question number 44. Clear? Question number 44. Yeah. What they are asking questions? The P and P bond angle in white phosphorus. And we have already given what is the structure of white phosphorus. Clear? White phosphorus is, and you know, monomeric discrete of tetrahedron. But if you take the red phosphorus and these tetrahedral units are linked together and to form a polymeric form. Clear? But you know, this is the structure, and phosphorus. Clear? So this is the structure of which one? White phosphorus. I mentioned white phosphorus highly reactive. Why highly reactive? This is actually phosphorus. All are having which bonds in here? All are with single bonds only. What should be the hybridization here? sp3. 3 single bond and 1 lone pair. Clear? And 3 bond pairs and 1 lone pair. Because here phosphorus is forming 3 bonds, means each phosphorus is having what it is? 1 lone pair. So that's why. And what is the hybridization? 3 bond pairs and 1 lone pair. So what it is now? 4. 4 means what is the hybridization? sp3. And if sp3, what is the bond angle here? 109.28 degree means that is 109 degrees 28 seconds should be the bond angle. But here the bond angle I mentioned clearly, it is 60 degrees. So that's why due to this bond angle, means angle strain, that white phosphorus is highly reactive. It try to break these bonds, because here due to the bond angle strain. Clear? That is option is. So 45. Phosphine produces smoky rings when it comes in contact with air, because you know, I already mentioned here, pure phosphine is inflammable. Means it is non-inflammable. Clear? It is pure phosphine is non-inflammable. I already mentioned. Clear? So it is pure phosphine. But phosphine is always contaminated with the what it is? Diphosphine P2H4. It is which is a highly inflammable. It is a flammable, means catch fire easily. So that's why due to the presence of P2O4 and PH3 will react with the oxygen and produces the, and here smoke of P4O10. Clear? So that is the reaction, and it contains impurity of what it is now? P2H4. So that's why it will form the, you know, it will burn in that time with the oxygen and gives the what it is now here, and the smoke of, means smoke is coming, means what it is? P4O10. Clear? So that is. So this is about the level 1, and go to the level 2. Level 2, see the question here 4. Clear? So level 1 completed. Now we are going to the level 2. See the question number 4. Level 2, question number 4. Because what I left, all those questions are belongs to which group? 14th group elements. So here 14 and 15th they have given combinedly. So that's why. And remaining questions what I left are, those are belongs to which one? 14th group elements. So now coming to the level 2. See the question number 4. Which of the following oxide do not act as a reducing agent? Clear? Do not act as a reducing agent. See what the oxides they have given. NO. Clear? So here they have given NO. Second one is NO2. Easily you can see here. And N2O3, N2O5. N2O5. You already know that nitrogen can exhibit all the oxidation states from the -3 to +5. Clear? No? So that's why if you see here in this oxide, this is a +2, and here what is +4, and here +1, and here what is +5. Clear? So oxygen can, nitrogen can exhibit the oxidation state from the -1, -2, -1, -1, 0 up to what it is here? +5. Yeah. So that's why. Here, what is the oxidation state here? +2. +2 means it can increase its oxidation state up to the 5, and it can also decrease its oxidation state up to -3. It is in middle, so that's why. If it is +2 here, and it can oxidize, and means it can reduce also. Clear? So N2O means its oxidation state is +2. Clear? So when it acts as a oxidizing agent, then it should undergo what is reduction. It can reduce. And if it is act as a reducing agent, and it should undergo oxidation, so that's why it can also undergo oxidation. It can NO can be, when NO is act as a supposed reducing agent, it will be oxidized to NO2. Clear? So options are. But you see in this case N2O5, because here also 4 is there and 1. They can undergo oxidation and they can undergo reduction. So that's why they can act as both the oxidizing agent and reducing agent. But you see for the N2O5, what is the highest oxidation for the nitrogen here? +5. So now in N2O5, nitrogen is in its highest oxidation state. Suppose if it act as a reducing agent, it has to oxidize. Oxidize means it has to increase its oxidation number. Here 5 means it should, when it undergoes oxidation number should go to the +6 or +7 here. Clear? But what is the highest oxidation state exhibited by the nitrogen? +5. So that's why, and beyond that it cannot go. Clear? So that's why, and it cannot act as a reducing agent. It can act as a oxidizing agent. When it acts as an oxidizing agent, it has to undergo reduction. Reduction means, and it can show the +3, -3, +1, +3, +2, +1. It can undergo reduction, but it cannot undergo oxidation. So that's why, and here N2O5 and it should not act as a reducing agent. Remember, whenever the elements in this oxides, whatever it may be the compound, suppose it is act as an oxidizing agent. If it is in its highest oxidation state, it always act as a oxidizing agent. It cannot act as a reducing agent. To act as a reducing agent, it has to show and higher than its highest oxidation state. It is impossible. So that's why your option is what is here, N2O5. Clear? So this is about the question number 4. Clear? So next one. And in the NH4 NH3, question number 5. See the question number 5. What is here? NH4 NO3, NH4 NO2, ammonium nitrite. The oxidation numbers of nitrogens. Clear? So it is a compound. How it will be dissociated? It will be dissociated into NH4 plus and NO2 minus. See the oxidation number here. You don't know what is the oxidation number of nitrogen, let it be X, and oxidation number of hydrogen is 4. So 1 into 4 into 1 is equal to what it is? +1. So X plus 4 is equal to +1. X is equal to what it is? -3. Clear? And if you see in NO2, X oxygen exhibits how much? -2. X plus 2 into -2 is equal to -1. X minus 4 is equal to -1. X is equal to what it is? +3. So they exhibit the +3 and -3 oxidation states. So what should be your answer here? Your answer should be option 3 is the correct one. Clear? Next one. Coming to the question number 8. Question number 8. So which of the following oxides of nitrogen is neutral? They have given 4 oxygen. I already mentioned so many times here. And among the nitrogen oxides, we have 2 neutral oxides. One is nitrous oxide or laughing gas, and another one is nitric oxide. Okay, so these 2 are neutral. Remaining all oxides, remaining N2O3 and N2O2 or N2O4, N2O5. These all are which one? Acidic oxides. These all are acidic oxide, but these 2 are neutral oxides. Clear? That is question number. Now, what is the option here? Question number 8, and the last one N2O. Option 4 is the correct one for this. Clear? Let's go. 8th one is completed. Go for now 12th question. Oxidation of NO in air produces. Oxidation of NO in air produces. What it is now? And here you will get the NO2, nitrogen dioxide. Take the 2 moles and add the oxygen. Then what will you get? You will get the NO2. So your option is option 3 is the correct one. Next one. 15th question. Question number 15. Clear? The strongest base is, means they are asking among this NH3 and PH3, ASH3, SBH3. Very clearly we mentioned in the PU classes. Clear? Acidic basic nature. Which one they are asking strongest base? Among these 4, which one is strong? Base means you know that this molecule does not have the OH group. So that's why, and you know we cannot use the Arrhenius acid and base theory. According to the Arrhenius, which gives the OH minus ions in the water, and those will be considered as a bases. But here there is no OHs, so that's why we have to take the Lewis, you know, what is it? Lewis acid and base concept. Clear? So in this case, you know that Lewis acid and base. According to the Lewis acid, electron pair acceptor is a acid and lone pair donor. Just here, lone pair donor is a base and lone pair acceptor is a acid. According to Lewis. Clear? So that's why, and all have here lone pair, one lone pair. So that's why they all can act as a bases. But they are asking which one is the strong base they are asking. Among these, which one is the strong base? Clear? You know that to get a means to act as a strong base, and they should donate its lone pair of electrons very easily. So all are having lone pair of electrons, but which donates lone pair of electrons very fast, and that is the strong base. To donate the electrons very fast, that molecule should have the, you know, highest electron density. If electron density is more, and it can easily give the electrons to, it can easily donate the electrons to others. Clear? Among this, but you know, all are having one lone pair only. But here, nitrogen size is small, and here SB size is, you know, here large. Clear? So that's why here lone pair is there. So this lone pair density of the small atom will be high compared to the what it was here. You see in this case, and the availability of lone pair is, you know, somewhere it will be. Clear? But here on the nitrogen, if anyone comes nitrogen, it catches its lone pair and it can donate, because nitrogen easily know where the lone pair exactly on his hand. Clear? On his hand. Clear? But if you go for SB3, SB size is large. SB to donate the electrons to others, it has to search where the electrons are present on his hand. Clear? So that's why it will take time to donate, but it donates the electrons very fast. So that's why which one is the strongest, you know, base? This is the basic strongest base is NH. Next, see the question number 22. Clear? Question number 22. So, which is the most explosive? I already mentioned when we discussed about the reactivity towards the halogens of the 15th group. So, I mentioned that all halides, trihalides, all trihalides of the 15th group elements except the nitrogen are stable. Means nitrogen trihalides are unstable. So among them, NF3 is the most stable. Remaining all are, you know, and you know trihalides of N ammonia is NF3, NCl3, NBr3, NI3. Clear? So nitrogen trichlorides are unstable compared to the, you know, trihalides of the phosphorus, arsenic, and antimony. Clear? But among these, NF3 is most stable. NF3 is what it is now here, most stable. And remaining all are very unstable. They are very unstable. So that's why, and in this case, NCl3 is a very explosive. Clear? So that is the NCl3 is highly explosive. Among the trichlorides, NCl3 is highly explosive. Clear? And see the now question number 29. Clear? White phosphorus when boiled with strong solution of caustic soda produces. Same previous only we have discussed. This is which phosphorus now? White phosphorus react with what it is? Caustic soda means what it is? NaOH. Clear? Then what the compound you will get? You will get the PH3 plus NaH2PO. So PO2. So this is clear. So and 3 moles here, 3 moles we have already discussed how to balance these molecules also. Clear? So this is about the phosphine. So what you will get here? You are getting phosphine is the product. Clear? Caustic soda means NaOH. Clear? So next one. This is preparation of phosphine. Very important for PE examination also. Clear? Next one. White phosphorus 33. Question number. Sorry, not 30. 33. Question number 33. Clear? White phosphorus react with caustic soda. The products are PH3 and NaH2PO2. The reaction is the example of. This reaction is the example of which one? Disproportionation. Why? Because you know it is 0. And here what is the oxidation state? -3. Because the oxygen is hydrogen is +1. It is total oxidation state here +3 valency and charge, and here -3. And if you calculate here, what is the oxidation state of the phosphorus? Calculate one. Sodium is 1 and hydrogen is 1, 2 hydrogen, and phosphorus 1, we don't know, let it be X, and oxygen is 2 into -2 is equal to what? 0. So 1 plus 2 plus X minus 4 is equal to 0. So X minus 1 is equal to 0 and X is equal to what? +1. Clear? So what is the oxidation state here? +1. So that's why, and phosphorus, first of all, it is undergoing 0 to -3 means what is reduction. It is what is reduction, and 0 to +1 is a oxidation. It undergoes reduction and what it is oxidation. So the same element undergoes both the reduction and oxidation, and those type of reactions we will consider it as a what is disproportionation reactions. You have studied in the first year. Clear? So this is about what it is here. Question number 33. Next one. Coming to the question number 36. Coming to the question number 36. Which of the following statement is wrong for the MO? It is a anhydride of nitrous acid. What is the nitrous acid formula? HNO2. HNO3 is a nitric acid. HNO2 is a nitrous acid. So it is, they are saying NO is a anhydride of HNO2. Check it whether it is correct or wrong. Clear? So now you see. First of all, anhydride means what you have to do? You have to remove the water molecule. To remove the water molecule, how many hydrogens should be there? 2. So multiply this one with the 2. Then remove water molecule, 2 hydrogens you remove. Then add in the form of water, H2, 1 oxygen. So now 2 hydrogens we have removed and 1 oxygen we have removed. Then what is there? Totally 4 oxygens are there. Now how many oxygens will be left here? 3 oxygens. And here how many nitrogens are left? 2 nitrogens. So that's why N2O3. Means N2O3 is a HNO3 is a anhydride of what is N2O3 is a anhydride of which one? HNO2, but not NO. So this is the wrong. Clear? So what they have mentioned here, which of the following statement is wrong means first one only. Dipole moment, it has dipole moment. Why? Because it is a polar molecule. Clear? It has dipole moment. Clear? It forms dimer. Yes, it forms dimer because you know this is a odd electron molecule. NO is a which one here? Odd electron molecule. Have you remember or not? We have discussed. NO is a odd electron. Simply it is. You know, nitrogen. Nitrogen, what it is? NS2, NP2. So, how many unpaired electrons are there here? Nitrogen. 3 unpaired electrons. So that's why nitrogen has to form how many bonds here? 3 bonds. But it is forming how many bonds here? 2 bonds. So that's why these 2 electrons are utilized to form the 2 bonds. 1 bond, 1 electron, unpaired electron is left on the nitrogen. So that's why this is a odd electron molecule. This is lone pair. Clear? This is 1 electron. Odd electron. When odd electron is there, then what happened? Same molecule, another molecule comes here. This is odd electron, and this is also having what is odd electron. So one electron means bond formation. It acts as which one? Dimer. Clear? So that's why, and it is a dimer. It is a paramagnetic, yes, of course. Why? Because you know it is an odd electron molecule. So that's why it is a paramagnetic. If any molecule is having the at least one unpaired electron, and it will show the paramagnetism. Clear? Next one. Coming to the question number 39. Clear? When mixture of carbon monoxide and chlorine is exposed to sunlight, the product formed is CO plus Cl2 in presence of sunlight. Means this we have discussed, and when we discussed about the chlorine and last chemical reactions, if you see last chemical means last reaction of last chemical reaction of chlorine, if you see there we have discussed the addition reactions of chlorine. So when we discussed about the addition reaction of chlorine, this reaction we have discussed. It is a simple addition, COCl2. That also we have discussed SO2 plus Cl2. Then also we will get SO2 Cl2, NO plus Cl2, and we will get here 2NOCl. All these reactions we have discussed or not? These are all reactions which reaction, addition reactions. So they are asking about this. So that's why carbonyl chloride can also be called as what is positive. This is what is positive. So what is the answer now? Option 2 is the correct one. So coming to the next question, 43. Question number 43. Clear? So in case of nitrogen, NCl3 is possible, but not NCl5. While case of phosphorus, PCl3 as well as PCl5 are possible. It is due to what it is, Magya? It is due to. Clear? Nitrogen can form NCl3 but cannot form NCl5. But phosphorus can form PCl3 and PCl5, and it is not possible. Why? Because I already mentioned nitrogen can form maximum how many bonds now? 4 bonds. And here NCl5 means nitrogen is forming how many bonds? 5 bonds. Nitrogen cannot form 5 bonds, because to form a 5 bonds and d orbital should be present. Clear? Nitrogen doesn't have the d orbital, so that's why it can form maximum 4 bonds but not the 5 bonds. And this is about the what is it here? Level 2. So next one here, some NEET and AIMT questions they have given. So see in the page number 31. Clear? Nitrogen family. They have given some questions here. Okay? See. Question number 10 is separately they have given 14 group and 15 group. See, which of the following statement is wrong? Clear? Which of the statement is wrong? Nitrogen cannot form D pi P pi. dP they have given, that is actually first option. D pi P pi bond. Nitrogen cannot form D pi P pi bond. Clear? Can nitrogen form the P pi? Nitrogen can form P pi P pi bonds, but it cannot form D pi because nitrogen doesn't have the d orbital. If nitrogen doesn't have d orbital, how can it come? How can it form? You know, D pi P pi multiple bond here, pi bond. It cannot form. So that is correct. Clear? They are asking wrong. The stability of hydrates increases from NH3 to BH3. Clear? Means stability of hydrates they are asking. NH3, you know, PH3, ASH3, SBH3, BiH3. Means they are asking, and stability order increases. Means and NH3 is least stable and BiH3 is most stable. They are asking. Clear? So we already discussed this question also, thermal stability. Clear? Now, in this case, you know that nitrogen is small because we have to see their stability means the N and H bonds you have to see, P and H bonds you have to see the stability or the bond strength of nitrogen and hydrogen, central element and hydrogen you have to see. Clear? So here nitrogen is small and hydrogen also which one? Yeah, small. Hydrogen also what is small. You know that when atoms are very small and overlapping will be very, you know, effective. When overlapping will be very effective, then the bond strength will be very high. Means overlapping effective means it will form very strong bond. Clear? So that's why, and this bond is very strong, and here this is this one, and here. So this bond, you know, it forms the 1s orbital it use the 2p orbital. Clear? So almost the sizes are similar, but you know this it is 6s and here 1s. It is s orbital. 6p orbital it has to use. Orbital 6p orbital means very large in size, and the 1s orbital means very small in size, and overlapping will be not that much effective, and you will not get the very strong bond. So which one is the strong bond it forms? Nitrogen and hydrogen bond is strong compared to the remaining, and it is the weakest. So which one is the other? Other actually has to be decreased. Yeah. So what they mentioned here, increase it they are asking. So it is a wrong option. Clear? So third option, single NN bond is weaker than single PP bond. That is also we mentioned. Single NN bond and here PP bond. Which bond is strong means this bond is strong. Why? Because you know these are two nitrogen atoms, small size compared to the what it is for phosphorus. So that's why here these are very small in size, and so that's why very small in size means they are very bond is strong means they are very close to each other, and you know nitrogen is having one pair of electrons. So and due to the small in size, and these molecules come very close to get a strong bond, form a strong bond. So that's why load pair means they are very close to each other. Load pair repulsions will be high. To avoid that, and this nitrogen will move that side, and this nitrogen will move that side. So that's why what will happen? These nitrogens move away from each other, so automatically bond length increases and bond strength decreases. But here you see these are larger atoms. Larger atom means they are away from each other somewhat compared to here. So repulsions will be here less repulsions, and here what it is here repulsion lone pair repulsions will be maximum in nitrogen and nitrogen, but here lone pair repulsions will be less in phosphorus and phosphorus. So that's why which one is weak? This one is weak and this one is strong. This is weak one, this is strong one. That is also correct. N2O4 has a resonance structure. Yes, N2O4 has a resonance structure because you know N2O4 means nitrogen and nitrogen, and there will be one bond, and here there will be a one bond. 3 bonds nitrogen is forming, 4th bond should be a coordinate bond. So coordinate bond can also be written as a N plus and O minus, and how I can write now here N plus and O minus. So this involved in the what it is resonance. It will show the resonance structure because you know lone pair double bond is separated by single bond, so that's why it involved in the resonance. So it has the resonance structure. So what should be your answer, ma? Option 2 is the correct. Means that is the wrong. Here, next one. Which of the following oxides is not valid for oxoacids of phosphorus? Clear? See now. Means which one is not correct? Not valid. Hypophosphorus acid. What is the formula of hypophosphorus acid? H3PO2. Clear? And this H3PO2, this hypophosphorus acid can also be called as this is phosphenic acid. Can also be called as what is phosphonic acid. Phosphorus acid can also be called as what is phosphonic acid. Phosphonic acid, and another one is phosphonic acid. Very important here. H3PO3 we will call as a phosphonic acid. Phosphonic acid. And H3, this is phosphorus acid can also be called mainly phosphorus acid. Another name is what is called phosphonic acid. Yeah, hypophosphorus acid, phosphonic acid. Got my point? So what they are asking, hypophosphorus acid is a diprotic. Diprotic means what it is? It has to donate means it has to give the 2 protons. Clear? See, means H3PO3. How to write the structure? Nitrogen and phosphorus. Nitrogen belongs to phosphorus belongs to which group? 5th group. Maximum how many bonds it can form? 5 bonds maximum. Clear? So now, and whenever we are there, oxoacids are there. You have to put there will be one double bond should be attached, double bond oxygen should be attached to the central atom, and there should be another OH. like COOH. If it is there, C double bond O and OH, this will be called as a carboxylic acid. It is an organic. But instead of carbon, any other elements are there, like nitrogen, phosphorus, and those we will consider as oxo acids of the phosphorus. So there should be a double bond O and OH. And the next one is, you see, we have used 2 oxygens here. Which one is left here? 2 hydrogens. Put it here, 2 hydrogens. Clear? So in this case, and H is attached to O, so that's why it can give only 1 proton. This is clear? So that's why it is a monoprotic acid. It is not a diprotic acid. So this option is first one is wrong. Second option is all oxo acids contain at least 1 P double bond O unit and POH. All oxo acids should contain 1 P double bond O and 1 OH, correct only. Orthophosphoric acid is used in the manufacture of triple superphosphate. Triple superphosphate. What is here? Orthophosphoric acid. What is here? Orthophosphoric acid. It can be used to prepare the triple superphosphate. Simple. If you take the ammonium, it is there, then what it can form? Ammonium triammonium phosphate. What is here? Triammonium phosphate. That we will call as a triple superphosphate. Then 3 phosphate means 3 salts it can form. So that's why we will call this is one salt, another one what it is? 2 hydrogens are replaced by the NH4. Then we will get the NO4. This is another one is if there is a only one ammonia and H2PO4. So this is clear. So it can form what is here? This is NH4H2PO4, NH4HPO4. All hydrogens are replaced. So that's why it will be called as a what is here? Triple superphosphate. All oxo acid, fourth option. All oxo acid contains tetrahedral 4 coordinate phosphorus. That also we have discussed. So option 1 is the not valid for all the acids of what is here? Phosphorus. Next one. See the question number 12. Question number 12 here. So nitrogen dioxide and sulfur dioxide have some properties in common. Which property is shown by one of these compounds but not other? Clear? You know that. Yeah, it is soluble in water. Both the NO2 is soluble in water and also SO2 is also soluble in water. Clear? It is used as a food preservative. SO2 is act as a antioxidant, so that's why it can be used as a food preservative, but not the NO2. Clear? So your option should be what it is here. Option 2 is what is and not same for the 2 compounds. Okay. Next one. And the 13th one. Strong reducing behavior of H3PO3 is due to. Just now we have discussed H3PO2, clear? Hydrogen and hydrogen. Clear? Is due to high oxidation state of phosphorus. What is the oxidation state here? -2, -1, +1 here, and +1, -3, +2. -1 means it is a +1. It is not highest oxidation state. Presence of 2 OH groups and 1 pH group. No. Presence of 2 pH groups and 1 OH. That is what it is. Option 3 is the correct one. High electron gain enthalpy of phosphorus. That is also not correct. It is due to what it is here. Reducing behavior is due to presence of 1, because this reducing agent is mainly due to of these 2 hydrogens. Clear? So that is. But in the option they have given like that. So next one is when copper is heated with concentrated HNO3. I already mentioned whenever copper is treated with HNO3 means it is a concentrated. You will get copper nitrate plus what you will get? You will get the NO2 plus what is H2. Concentrated means NO2. If you take dilute means dilute, then what you will get? CuNO3 twice plus what is here? NO plus H2. Yeah. Concentrate means NO2. Dilute means what is N.